All right, 19. It says United States population is aging. Here's a STEM plot for the percentage of residents aged 65 and older in the 50 states and districts of Columbia. So there's 51 data points. Um, the stems are whole percents and the leaves are tenths of a percent. So for instance, this right here would be 16.8%, whereas this one right up at the top here would be 6.8%. You always have to pay attention to that so you know exactly what you're reading on a stem plot. And the question, which is not it's on the next page, but it's right over here. Alaska is an outlier. So for instance, not for example, which one is the outlier? And that would be this guy right up here because the outlier is the data point that's far away from the rest of the data. So 6.8% is the outlier, and that'd be A. All right, there we go. I'm actually going to continue on the next page because it's related to it. So 120, ignoring the outlier, what's the shape of the distribution? Skewed to the right, symmetric, or skewed to the left? So I'm going to go back, and we're going to look at this, and we're going to kind of look at this distribution. If I ignore the outlier, what's the shape of this? And if I kind of draw a line kind of along the top like that, what does that look like? And I can actually turn this, and if I do this, let's see if this is going to work. Oh, I turned the data but not my graph, so that was an epic fail. So let's go back. Sorry about that. It didn't turn my writing. Um, so basically, what does this look like? Is it symmetric or skewed to the right or higher numbers? That's the way the tail goes. Skewed to the left or lower numbers. That's this. This is skewed left, skewed right. And then this, of course, would be symmetric. Would be anything. That's not a very good symmetric drawing, but it looks something like that. Or it could be symmetric. Might even be like that. So any of these would be symmetric looking. So in this case, it would be symmetric. Roughly symmetric. The center of the distribution. The center of the distribution. I'm going to wipe off that guy and all of my other stuff on here. The center of the distribution is roughly where the middle data is, and I'm just going to count from the bottom. I know there's 51 pieces of data, so I'm going to count roughly 25, 26 pieces of data in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Oops. So basically I've got 25 pieces of data this way, and since I know there's 51, I'm going to have 26 pieces of data on that side. So the middle is going to be right around there. That way I've got 25 to the right, 25 to the left, and that's kind of my midpoint there, right? That's called the median of my data set. Okay, so, and that would be 12.8%, the middle. Okay, or the center of the distribution, 12.8%. Okay, and 22, if you look at real estate ads for houses in Naples, Florida, there are many houses ranging from $200,000 to $500,000 in price. The few houses on the water, however, have prices up to $15 million. The distribution of house prices will be skewed to the left, roughly symmetric, skewed to the right. Well, if you look at housing prices, it says many houses from 200,000 to 500,000. This is kind of what you're thinking. There's a whole bunch of houses in this range, right? But because of the water, there's a few houses that are way up here at 15 million. So there's going to be a few houses somewhere up around here like this. So what is that distribution going to look like? Will there be some in between? Yeah, there may or may not be. but it's going to look like this and then kind of come way down here if I were to kind of try to draw a smooth curve that will estimate what that data looks like. And that is what we say skewed, as we say in class, towards the larger numbers. And since we always write the larger numbers to the right, it's okay to say skewed to the right, but it's more accurate to say skewed towards the larger numbers. So that would be C there. All right, there we go.